I'm here with a presentation of this model. This model is of two panels which will be used for the building. These panels are just standard panels, they don't have any windows, doors, they're just walls which would be used to make usually the sides which would connect to other buildings. So if you imagine this is the front of the house, this is the side of the house, it would connect to another house that would be here. So this model helps me to understand how panels will connect to each other using metal connections, such as these corner brackets here. These would be large corner brackets. These holes in them would be much smaller, they're not to scale. Those would be for putting in screws or nails, depending on what people would want to do with it. So if they have a lower budget than nails, if they want to put screws which are longer lasting, they can use screws. And there's one on the interior and the exterior. This helps the two panels to be connected more securely, and they would connect like so. Then nails or screws would be placed, holding them together. These brackets would also extend down into the ground, which would allow for them being sunk into concrete, so that would be a form of foundation, as well as if this was the bottom floor, because these grooves wouldn't be used, this part of the model building would also be sunk into the ground with concrete to help it stand straight. So this is how the panels will connect to each other on a corner. And to finish off, there would also be another bracket to make this a right angle, like there. So it's a nice corner there, not an interior corner, an exterior corner. And in there could be placed insulation of any type, as long as it's solid, to help insulate the building. And also that corner makes it more easy for decorating, plastering and such. Connecting these kind of panels on a parallel, like so, would be done using smaller metal connections like this. Again, the holes aren't to scale, they're just representing holes that would be there for nails or screws. And wait, it's quite wobbly. And these would be placed on intervals, so one would be in the middle, one would be at the bottom, one would be at the top, and the same would be done on the exterior, so the outside of the building. This again helps it to reduces the wiggle room, so if it's on the interior it still allows it to move a bit, whilst if it was on the exterior and the interior it stops movement of the panels, as metal doesn't really stretch, so the metal will stop the panels from moving apart because it won't stretch, not allowing that to happen. So that's how the panels will connect to each other. Now if the customer wants to put a second floor on the building, what they would do, is the joist, the floor joist, would be first, this is sunk into the ground, then the joist is placed into the building, into the grooves, like so, and then another panel is placed on top of the existing one to hold it in place. These would also be held with metal connectors, so that would attach this panel to this joist, and it would also attach this joist to the other panel adjacent to it. So this panel, allowing for a strong bond, as each panel would have 4, ideally 5, as in the later models. The model of the whole building has 5 grooves per panel, so there's 5 connection points for the panel to be attached to the top floor. The metal fittings are mentioned in the other model, the cross section with all the interior components, because it would just be too small of a component to put into these. These are also not to scale, as they're just representing. The thickness would be 3mm steel in reality, whilst this is probably 1mm. And obviously it's not to scale of this building, which would be 5 meters across and 2.5 meters tall, plus minus 2-3mm. Larger inaccuracies are allowed on these because obviously it's a bigger building, and this model can have really small ones, but in the real model, thing, there would be much bigger inaccuracies because obviously it's bigger, so the amount of inaccuracies allowed is also increased. So that's how the panels will connect to each other, and the joists, which would be going across, would also have decking floors on them, and they would be supported on the other side by the other wall on the other side of the building, like so. And this also limits wiggle room. It doesn't limit it much because it's only one joist for now, but it limits the wiggle room. It stops them from moving apart if it was secured down onto the models with those metal fittings, as shown in the other model. Thank you very much. That's the panel.